Good morning, everyone. My name is Varun, and in this presentation, I'll be talking about my project, which is Weather Alert and Recommendation System. The main goal of my project is to build a automated weather alert and recommendation system wherein users sets their preferences in the front end, and based on their preferences, they get an hourly weather alert if the preference matches, and they also get 1 day before daily weather recommendation notification for the outdoor activities. If the weather recommendation matches, if they get a notification that it is suitable for outdoor activities. If not, they get an email that it is not suitable to go for outdoor for activities for the next day. So the overall goals are to implement hourly weather alerts and daily recommendation system based on preferences, integrate it with Open Weather API for real-time weather and for weather and forecast data, schedule all scripts with Google Cloud Scheduler. I have 3 scripts in my overall project, and cache hourly weather alert matches in Redis for temporary purposes, and store the persistent memory, that is user preferences and the forecast data in MySQL, and to deploy, and finally to deploy everything in Google Cloud services like Compute Engine, Cloud SQL, Redis, and Cloud Scheduler. The software and hardware components which I use for my project are, for the coming to the software, I have used Flask API, SMTP, I have used Python, I have used Cloud SQL, that is MySQL specifically. I have used Redis with Google Cloud Memory Store. I have used OpenWeather Map API for weather data. I have used Cloud Scheduler. Now, when it comes to hardware, I have used uh, uh, Google Cloud Engine, E2 Micro specifically, and Cloud SQL with 100 GB capacity, and Google Cloud Memory Store for Redis with 1 GB capacity. Now, this is the overall architecture diagram of my project. We can see that I have deployed my API, which is a Flask API in Google Cloud, in Google Cloud instance, E2 micro instance. And initially, what happens in the system is the user first submits the preferences. Then the Flask API receives a request, and based on the schedule time, the scripts are run automatically. So for hourly checking, first the hourly weather alert script is run, and so what happens when the script is run is, if the preferences of the user matches, it is stored in the Redis memory store. Then an email is sent to SMTP, specifically Gmail in this case, for that hourly weather alert. Uh, so what happens if you want to send in daily recommendations? The daily recommendation script is run. Then that details are stored in Cloud SQL, and the email is sent. Now, all of this data is being taken from the OpenWeather API map. Whenever a weather data is needed, it is fetched by Flask API through OpenWeather API map. So this is the overall architecture of my project. When you come into the interaction between various components, you can see here, as I've already discussed before in the architecture diagram, what happens is first the user submits the preferences to Flask API, then the Flask fetches data from OpenWeather API map, then the Redis caches data for hourly checks. So if the preference matches, it is stored in Redis. Then if you want for daily recommendations, the data is fetched to OpenWeather map, and it is stored in Cloud SQL, MySQL here. Then what happens? Then all of these is run through automatically through scheduling. I've set the hourly checks to run every hour, and daily recommendations and fetching of forecast data to run once a day in my project. Now, coming to the debugging and testing, which I've done, coming to the debugging process, I have manually executed scripts to verify functionality. I have added print statements in various app.py and my scripts to verify functionality, to track API calls, to see data retrieval and pre-processing. I've also verified API URLs, parameters, coordinates, and weather data for correctness. Debug database operations by testing SQL queries independently in the console specifically. I have validated Redis operations using Redis CLI to confirm whether the data is actually stored or cached temporarily or not. I have even simulated edge cases for my API. When it comes to testing mechanisms, I've used unit testing. I've tested individual functions like sending email, API fetching, and all that. I've also did end-to-end testing by performing complete mock test by setting preferences and testing whether I receive the email or not. And I have used Google Cloud Interactions as well for cloud scheduling for automatic triggering. Now, let's move on to the demo here. Now we can see that this is the Google Cloud Console over here. You can see my cloud scheduler has the jobs here and my VM instance over here. This is the Flask with the API VM instance, and this is external IP here. This is my Cloud SQL, which is already running. And this is my Redis, which is running here. Now this is the external IP. As you can see, this is the external IP here. I have used port 5000 here. So this is my front-end UI. So whenever the user he gets his front end, we just type the user ID, city, email, minimum temperature, maximum wind speed, and rain alert. I've set 0 because no rain alert. I don't need a rain alert. So if I submit, the preference is submitted. Now to test whether I receive the email or not, we can test using this. I'll just send a post request to my to run the script manually. I'll just send a post request. To run the hourly scripts, I'll just use this. The script is running, so the hourly weather alert script is triggered. As we can see, this is my email. I've just received an email here from weather alerts.gss, which I have created. It's my own email which I've created. As you can see, I just got a weather alert saying the city is Denver, the temperature is this, the wind speed is this, and rain alert is no. It means there is no rain in that specific city. Now, if I want to test daily recommendations, I just go here and execute that script. Run daily. Okay, so I got the script name wrong. Yeah, so I just run in the daily weather recommendations. This is the correct name of the script. It is running. We can see I got a message that daily recommendation script is triggered, and I'm just waiting for the email over here. As we can see, I just got an email saying good news tomorrow in Denver. It is a great day for outdoor activities. This is the temperature, wind speed, and weather condition. So in this way, the user receives the emails through my app. Now moving on, let's talk about workload and bottlenecks. Uh, the current system handles up to 1,000 API calls per day, and the Redis storage for temporary caching is just 1 GB, and SQL storage has 100 GB. And potential bottlenecks include scaling if API limits are exceeded, that is, if it is more than 1,000, and Redis storage may fill up, and it might cause higher alert frequencies and email sending rate under higher user loads. Now, closing and scope overall, my main accomplishment is I've developed a fully automated weather alert and recommendation systems. As I have shown that I've scheduled my jobs through Google Scheduler, so they are daily. The user receives hourly alerts or daily recommendations. Future scopes include improving the front end and developing an app or using multi-language support. Thank you. This is the end of my presentation.